Okay guys, so we are going to talk about angles of regular polygons. This stuff will definitely be on your exam. It's very easy to learn and you need to know it. So I hope you're watching these videos. Alright, so let's get started. This is section 6.1 of your book. Alright, and there's something called the interior angles sum theorem for any polygon. Okay, a polygon, remember, is just a closed figure of so many sides. So you could have a triangle or a rectangle or a pentagon, hexagon, heptagon, dodecagon, whatever, right? It has a certain number of sides. And, you know, the sum of the interior angles in any n-sided convex polygon, so a regular polygon, is given by the number of sides minus 2 times 180, okay? Where n is the number of sides. So for example, we know by the triangle sum theorem that all the angles inside of a triangle have to add up to 180. Well, why is that? Well, a triangle is a polygon and it has 3 sides. So if I use that little formula and plug the 3 in for n, I get 3 minus 2, which is 1, times 180, gives me 180. If it's a 4-sided figure, then I have 4 sides. So 4 minus 2 times 180 is 2 times 180, or 360. And you know, you can think of it this way too, that any kind of a quadrilateral, a 4-sided figure, which we're going to talk about more in depth in a minute, is really just 2 triangles attached to each other. So if this is 180 and that's 180, when you add up 180 times 180, you get 360. In a pentagon, you know, you have this triangle here, and then you have those 2 triangles, or you could have done the diagonal that way and had those 2 triangles. But anyway, 3 triangles. If each triangle is 180 degrees, then 3 times 180 is 540. But rather than that, just take the number of sides of a pentagon, which is 5, subtract 2 from it, multiply it by 180, and you're going to get the same value. Okay, so you know, I could have gone on with hexagon and heptagon and octagon and nonagon and all that stuff. It's the same thing. It's just the number of sides minus 2 times 180. You need to remember that formula, because remember, you get no formulas for the exam. Okay, so an example would be find the interior sum, so the sum of all of the inside angles, all of the interior angles of a heptagon. Well, we remember that a heptagon, hept means 7, right? So the number of sides of a heptagon is 7. So I just do 7 minus 2, which is 5, multiply it by 180, and I get 900 degrees. So I can't draw a heptagon. Well, let me try. Let's see, 1, 2, 3, 4, 5, 6, 7. Ugh. If I add this angle plus this angle plus this angle plus that angle plus that angle plus that angle plus that angle, if I add all of these inside angles up, they should equal 900 degrees. That's all it means. Okay? Another way you may see this is using a little bit of algebra. So here's a pentagon. It's pentagon A, B, C, D, E. We name polygons, remember, by however many vertices is, by the vertice letters. So we want to find the sum of the interior angles and then find x. Well, this is a 5-sided figure. So I know that even though I don't know what these individual angles are, I know that they all have to add up to 540 degrees. If I use my little formula, 5 minus 2 times 180 is 540. So now all we have to do is say 2x plus 142 plus 2x plus 3x plus 14 plus 3x plus 14. So that's what I did here, is equal to 540. Okay? Then I can combine like terms. I added all the terms containing x together and got 10x. I added all the numbers together and got 170. And now if I solve for x, I get 37. So, you know, if they wanted me to find, say, angle C, I would do 37 times 2 to get angle C. So what I did over here to the side, this stuff here, I just did that. I said the measure of angle A is 74 degrees. 2 times 37 is 74. Well, the measure of angle C is going to be the same because they have the same constant. The variable has the same constant, right? So this is 74 and that's 74. If I wanted to find the measure of angle D, I do 3 times 37 plus 14, which is 125. And since those two angles are the same, I know that's going to be 125. And just to check my work, I could say 125 plus 125 plus 74 plus 74 plus 142. Does it equal 540? And it does. Okay. If it doesn't, then you know, you would have an error somewhere. So you can check that really, really easy. Those are the interior angles. Here's another one, another example. So here we've got a regular polygon, okay? You have to remember, in a regular polygon, all the sides are going to be congruent. All the sides are going to be equal, and all of the angles inside are going to be equal, okay? So that's why I wrote 120 for each of these. But before that, it says, what is the measure of each angle of a regular hexagon? Hexagon has 6 sides, so 6 minus 2 is 4, times 180 is 720. So I know all of these angles have to add up to 720. So all I do is take the total sum of the angle measure and divide by the number of sides. And that's how I got to find the measure of each individual angle. Very, very important, so make sure you know this. Okay? So, any polygon, we've done this before, any polygon can have its sides extended, right? And when we do that, it forms these exterior angles, okay? What you need to know is that, so, you know, this is just a triangle. It has 3 sides, so it's going to have 3 exterior angles. If I had a square, it would have 4 exterior angles. If I had a pentagon, it would have 5 exterior angles. If I had a dodecagon, it would be how many? What's dodecagon again? 12 exterior angles, okay? And no matter how many sides you have of any polygon, the sum of all of the exterior angles always equals 360 degrees. So even if I have a dodecagon with all of these miserable little, you know, exterior angles, they always have to add up to 360, always. Okay, that's the exterior. You know that the interior, for a triangle anyway, has to add up to 180. So the exterior measure is different than the interior measure, and the exterior angles always have to add up to 360 degrees. Okay, so this is from your book. Find the measure of each exterior angle. A nonagon, that's 9 sides, right? Has 9 congruent sides. Let's try this. Looks like it's a little bit blurry. There we go. So a nonagon has 9 congruent sides and 9 congruent interior angles. Find the measure of each exterior angle. So all you have to do is let n be the measure of each exterior angle, right? We know that the number of sides times the exterior angle, one exterior angle, we know that all of the exterior angles have to add up to 360. So it's the number of sides times the measure of each exterior angle. I don't know what the measure of each exterior angle is, but I know there were 9 of them. So it's 9 times the measure of each exterior angle is equal to 360. So 360 divided by 9 is 40. So if I could draw a nonagon, and I can't, each, let me see, here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, those aren't congruent sides. But anyway, if I extend every single one of these sides, I'm going to have all of these exterior angles out here. Here's one, here's one. So it's a terrible picture because it's a very hard thing to draw. But anyway, if all of these exterior angles have to equal 360 and there's 9 sides, I just take 360 and divide by the number of sides, is essentially what I'm doing. So this would be 40, and 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 all the way around. And if I add up all of those 40s, 40 times 9, I should get 360. So to find the measure of each exterior angle, just take 360 and divide it by the number of sides of whatever they give you. So, you know, what about a pentagon, right? How about we do the same thing for a pentagon? Well, a pentagon has 5 sides times n equal to 360, right? I know the exterior angles of a pentagon is 360, so n would just be 360 divided by 5, and that would be 72. So each exterior angle would be 72 degrees, and here's my little pentagon, right? If I extend this side and this side and that side and that side, and let's say that side, then this would be 72, and this would be 72, and that 72, and that 72, and that would be 72 degrees, okay? 72 times 5 is equal to 360. Very simple concept, and you're going to do some practice on the practice worksheet for angles of polygons which are posted on Edsby. In this video, we're going to talk about quadrilaterals. This is section 6.2 in your book. Quadrilaterals, so I'm just going to start off with doing a very quick overview of the quadrilaterals, and then we're going to focus specifically for this video anyway on parallelograms, okay? So what is a quadrilateral? It's a four-sided figure. It has four sides, it has four vertices, and it has four interior angles, okay? Now there's different types of quadrilaterals. There are parallelograms, there are rectangles, squares, rhombus, trapezoid, okay? But we're going to focus on the parallelogram, and I've got more stuff going on down here, but we're going to focus on this, and I'm going to pull your book over. A parallelogram, very, very important. These are used a lot in geometry. What you need to know about parallelograms. Well, parallelograms have opposite sides that are parallel, okay, so opposite sides are parallel. Opposite sides are also congruent, so if this is 6, that's 6, okay? If this is 2, that's 2. So these two sides here are parallel, and those two sides are parallel, okay? Opposite angles are congruent, okay? So angle A is equal to angle C, and angle D is equal to angle B, okay? By the way, what I know is that, right, if these lines are parallel here, then I can think of this as a transversal, right? We have already learned about parallel lines. What kind of angles, if this is a transversal, what kind of angles are those? Those are consecutive interior angles, CIAs, right? So the consecutive interior angles are supplementary. These two add up to 180, and those two add up to 180. So that's what I did right here. They're CIAs, okay? Don't forget that. And the diagonals are going to bisect each other. Well, so here's a diagonal here, right? And here's another diagonal here. And what does it mean bisect? If this diagonal bisects that, that means this piece is equal to this piece, and this piece is equal to that piece. So because they bisect each other, they cut each other into two congruent pieces, okay? Diagonal DB is cut into two equal pieces, and diagonal AC is also cut into two congruent pieces. Now, I don't know, you know, maybe this piece is the same as that piece. I don't know. All I know is that the pieces of this diagonal are equal and the pieces of that diagonal are equal. Okay, so let me pull the book. Let me just set that aside. And this begins on page 399 of your book. Okay, and there's a little synopsis here at the bottom of that page. Okay, so let me just move the camera. This book just never fits on anything, does it? Okay, so there's this on page 399. Everything that I just said is listed here, okay? And by the way, if a parallelogram has one right angle, it has four, because this is a rectangle, and rectangles are parallelograms, okay? They fall under that category. So everything I just went over is there on page 399. All right, on page 401, I'll move the book here. Here we go again, that the if a quadrilateral is a parallelogram, then the diagonals bisect each other. Okay, this diagonal bisects that diagonal. Okay, and also because this is a four-sided figure, the diagonal is going to cut the parallelogram. One of the diagonals, so either this one or that one, is going to cut the parallelogram into two congruent triangles. I mean, that's pretty cool. Okay, so a type of example that you might come across is something like example 2 from the book. You might get a picture like this, and this one says if QRST is a parallelogram, so they're telling you it's a parallelogram. So what do I know? I know that opposite angles are equal, I know that the diagonals bisect each other, I know that opposite sides are parallel and congruent, right? Find the value of the indicated variable. Okay, so anyway, you know, I've got y's here, a z here, an x here. Well, pretty simple. Let me see, let me get my pencil. Pencil. Uh-oh. I can't pick that up. Right, I don't know where my pencil is, so I'll just pull a piece of paper here and do it this way. Okay, so the first thing I know to do, I'm just going to look at this picture, right? And I can find x really easy. Since this is a parallelogram, I know that TQ is congruent to RS. So I know that 5x is equal to 27. So x is equal to 27/5. Okay? And if I use my calculator, you'll get 5.4 like you see here in the book. Okay? So I know that this is 27/5. And by the way, 5 times 27 over 5, the 5's cancel and you get 27. So those two are equal. Okay, so x was real easy to find. Now I'm going to try and find y. Well, what I know is that here's a 2y minus 5 and this is y plus 4. And I know that the diagonals bisect each other. So what I know is that this piece of the diagonal is equal to that piece of the diagonal. Pretty simple. 2y minus 5 is equal to y plus 4. Okay, and if I solve that, I'm going to subtract y from each side, so I'm going to have y minus 5 is equal to 4. Adding 5 to both sides, I get 5 plus 4 is 9. So what I know is that y is 9. Now if I plug the 9 in here, I get 18 minus 5 is 13, and 9 plus 4 is 13. So I know that this piece of the diagonal is 13, and that piece of the diagonal is 13. And if I needed to find the whole diagonal, I'd just do 13 plus 13, which is 26. Okay. Now I'm asked to find z. Okay, well z is an angle because it's in degrees. And what I know is that opposite angles are congruent, right? Let me just move this paper here a little bit. So remember, if these are parallel lines, right? This could be a transversal, so to speak, right? So I know that opposite angles are congruent. So it's not this and this. I know that this whole thing is equal to this whole thing, right? And by the way, if this is 3z, since these diagonals are going to bisect the angle, or I'm sorry, no it's not, my bad. What I know is that this angle and that angle, those are alternate or opposite angles. So all I have to do is say 3z is equal to 33, so z is equal to 11. Okay. Now look, 95 plus 33 is 128. So what I know is that angle Q here, this whole thing is 128 degrees. So I know that this whole thing here has to be 128. So if I needed to find this angle, I would just do 128 minus 11, right? I know that z is 11, so 11 times 3. So 128 minus 33 is going to give me 95. You see how that's 33 and that's 33? That would be 95 and that would be 95. Okay? Piece of cake. Let's see, what else do we need to do? Here's one. This is a parallelogram here, so this is from your book on page 403. It's number 2. They want you to find the value of the variable. Okay, they're not giving you what k is. I know what k is. It's 105 degrees, right? I know that all of the angles inside of a quadrilateral have to add up to 180 plus 180 or 360, but that's neither here nor there. I know that opposite angles have to be congruent, so if I want to find x, I just say 2x minus 1 is equal to 75. Right? So 2x is equal to 76. So x is equal to 76 divided by 2 is what? 38. Okay, it's really pretty simple. So those were angles. This next problem, you notice we're not talking about angles anymore, we're talking about sides, right? I know nothing about the angles here. But if I'm trying to find y, I know that opposite sides are congruent. So I know that y minus 4 is equal to 11. If I add 4 to both sides, I get 15. So 15 minus 4 is 11, and that's 11. So these sides are 11, this side's 8, that side's going to be 8 because it's a parallelogram and opposite sides are congruent. Okay, so you're going to do a worksheet on just parallelograms, either finding sides or angles. I'll put the answer key up on Edsby. That way you have it to make sure you're doing the work correctly. And if you have any questions, don't hesitate to contact me. Okay? Have a good day.